Hello everyone, I'm Sharanya PS. In this session, I will be discussing about two-dimensional arrays. In the previous few video lectures, we have discussed about one-dimensional arrays, how we can initialize and declare the arrays, and how we can access the data elements in the arrays, and different programs along with the different searching and sorting programs. And here the topics that I cover are declaring and initializing two-dimensional array, what this two-dimensional array means, sum of two different matrices, transpose of a matrix, and how we can copy a matrix. What is meant by this two-dimensional array? Array is a collection of elements of same data type. Suppose if we want to store a lot of elements together, in such situation we will be using the arrays. In the one-dimensional array, we are able to store elements with only the rows. That is, we will be mentioning the size well in the beginning. To that particular size, we can keep adding the elements, which will be depicted like as it is stored with a table which contain only the rows. Coming to the two-dimensional array, here we could able to store the element in a rows as well as the columns. So, this two-dimensional array will contain the set of rows as well as the set of columns. In the rows, we could able to store the values, and even in the columns, we could able to store the values. It looks just like a table which contains the rows as well as the column. These two-dimensional arrays need to use majorly two indices. Why two indices are required? As I mentioned here, it will contain rows as well as the columns. So we need to refer these rows and columns with the two different indices. Say for example, I is the index which is used to represent the rows and j is the index which is used to represent the column. Based on these two different indices, we could refer to the rows and the columns present in the two-dimensional array. So, these two-dimensional array we can also call as array of arrays, because in one-dimensional array there will be only one size specified. To the given size there will be that many number of elements or the blocks will be present in the array. Whereas here there will be two sizes will be mentioned. So it is nothing but array of arrays. And these two-dimensional arrays are also called as matrix, which is nothing but which is a combination of rows and columns. If you look into the declaration of this two-dimensional array, as we followed in the normal array or one-dimensional array, first we have to specify the data type and then array name, and then we have to mention the size. That was applicable for one-dimensional array. Now, coming to the two-dimensional array here, after mentioning the data type and the name, here we have to specify two different information. That is, first we have to specify the row size and next we have to mention the column size. Both need to be specified in the square brackets. Now, here, coming to the taking one example here, we have mentioned the data type as a integer and array name is mentioned as a and here we have mentioned within the square bracket as 2 and within the second square bracket we have mentioned 3. What does it mean? That is, this array will contain 2 rows and 3 columns. So, by mentioning this statement, that is int a of 2 and 3, it says it is a two-dimensional array with 2 rows and 3 columns. So it will display a matrix kind of structure with the 2 rows and 3 different columns. And as we observe how we can identify the total number of elements present in the 2D array. That is the next question that we should be clear about. Here, as we observe here, there are total, how many rows are present? There are total 2 rows are present. And how many columns are present? There are total 3 columns are present. So, by using these 2 indices values, we could calculate total number of elements present in the array. That is 2 into 3. That is number of rows into number of columns. That will yield you the total number of elements present in the array. This is how we could identify the complete number of overall elements present in the array, in a two-dimensional array. And one more point, how to calculate the size of the array. As we know, this integer will be having 2 bytes of array, 2 bytes of memory location is required by the integer. Here, this array totally will contain how many elements? As we discussed now, it will contain total 6 elements. So, each element will have how many bytes of data memory storage? 2 bytes. So, 2 into 6, that is total 12 bytes is the total memory usage that is done by this entire array, because it will contain total 6 elements. For storing each element, we require 2 bytes. As a whole, if we refer, it will be 6 into 2. Here, 3 major questions we have referred. How to declare the array, how to calculate the number of elements present in the array, and what is the size of the array. Next, moving further, we'll take one example and we will look into how we are storing the values to each of this array. As I mentioned, this two-dimensional array will be consist of rows and columns. Rows, here is nothing but 2 rows are mentioned, and here the second indices that we are representing during the declaration of the array is responsible for column. That is nothing but here it is a 3. It is a matrix that we can also refer as with the 2 rows and 3 columns. Now coming to the one element present in the row as well as in the column. As we refer this element in the matrix, how we can represent that element by using the index values. That is, as we discussed in the one-dimensional array, if we want to access any elements present in the array, we can access it by using the index value. Index value are beginning from 0. The same will hold good here as well. The column index will begin from 0. Same way, the row index will also begin from 0 onwards. Here, if we want to refer the very first element in the matrix, we can refer it by using, which is having the row index value as 0 and the column index is also 0. That is, we can say it as the name of the array is A and the rows index is 0 and the columns index is 0. This is nothing but the element stored in this particular location. This is how we can retrieve a particular data present in any of the rows and the column. That is, if we want to access any element present in the entire two-dimensional array, we have to mention the corresponding row number and the corresponding column number, which will allow us to access any element present in the array. Same way, while storing also, we have to process in the same manner. And here, one major care we have to take, that is, when mentioning the 2D array, we have to mention the second column dimension. That is second second indices what we have specified is responsible for mentioning the columns. Why it is so important? Here, if we look into the example here, it is containing 2 rows and 2 columns. And while entering the data, here it will start entering from the very beginning. And it will keep entering the data like this. And if we are mentioning the column number, then it is easy to split the rows to the next value. That is, in the very beginning, the row value will be 0. And it is clearly mentioned that the column will be only 3. Then, after entering till here, it is clear that it need to enter to the next row, next 3 elements. That is, here by mentioning the column number, we could clearly split the values that we are entering to the rows. That is why even sometimes we can skip the row in these value, index value what we are mentioning the row size, but not the column size. If we are not mentioning the column size, then it is not clear where to enter the next value. Next, we have seen how we can declare the array. Now, if we come into the initialization of 2D array, it can be done in 2 ways, either during the compile time or during the runtime. First, let us look into how we can initialize the array during compile time. This can be categorized or performed in 3 different ways. Basic initialization, initialization without mentioning the size, and partial initialization. First, let us look into the basic initialization. Here, we have to mention the array size and all the values during the initialization. In the very beginning itself, we are mentioning the array size, and then along with that, we are specifying the values as well. Now, if we look into the example here, int is the data type, A is the array name, and here we have specified the 2 sizes. That is, first 2 refers to the row size, and second element, that is 3, refers to the column size. So it indicates it is an array with the 2 rows and 3 columns. Now after that, with the equal to symbol, we are assigning the values whatever we are mentioning to this particular array. We have specified continuous values, that is 6, 4, 2, 1, 8 and 26. That is, it will start entering the values in the very first location, that is A of 0, 0 location. That is, with the row value as 0 and the column value as 0. In that particular location, it will enter 6. And it is mentioned that there will be total 3 columns. So, 6, 4, 2 will be present in the first row, and 1, 8, 26 will be present in second row. Next, one more, much more beautifully, we can mention this representation in a very detailed manner by using this way. Here, the same 2 cross 3 matrix, even it refers to, that is with 2 rows and 3 columns. Here, this array also. But here we have specified the content of the this array in a more specific manner. That is, clearly we are mentioning this inner braces here. It refers to the elements that we are mentioning to the first row. And after that, we have put the comma, and then we are mentioning the elements to the next row. That is 40, 50, 60 will be sitting in the second row. This is how in more specifically we can mention the content to the array. This is how we can specify the values to the array. And one more thing here, by mentioning 2 cross 3, it is well understood that there are total 6 elements present in the array. Next type of initialization is without mentioning the size. As we discussed, here mentioning the row size is not a compulsory, whereas the column size we cannot omit, because the column size is much important to distribute the elements what we are storing in the array. Here in the second category of initializing, the first row size what we are mentioning is not mentioned, but strictly the column size is specified. Now the same matrix or the same row array what we have referred previously, that same example we are referring here with the data type as a integer array with the array name as A, and we are not mentioning the first size of the array, that is first index is kept blank and the second index is given as a 3, and we are entering the values like this. So total there are 6 elements, and the second index it is mentioned as a 3. That indicates there will be 3 different columns. So which is very clear that by distributing 3 different columns values, we can arrange 2 rows from this different values. So it will compiler will understand that it will contain 2 rows and total 3 columns and distribute these values accordingly. This is how we can perform the initialization without even mentioning the column row size, but compulsorily we have to mention the column size. One more is last category is a partial initialization. That is, we are not mentioning all the elements of the array in the very beginning. That is, here in the first row we have mentioned only 2 values, that is 1, 2, and in the second row we have mentioned only the element 5. If we are specifying like this, all the other elements will automatically set with the values 0. This is the partial way of initialization. Like suppose if we mention here only one element, or 5, 10, if we mention here, the 10 will be updated and this last element will be set it as 0. Because it is already clear that it will contain 2 rows and 3 columns. But the number of elements present here is lesser than the actual element supposed to be present. It will enter the elements whichever it is initialized. All the other elements will be set with the value 0. So this is how we can perform the compile time initialization. Compile time initialization we have looked as a 3 different categories. First one is a simple type, and second one basic initialization, and second time is initialization without mentioning the size, and one more as a partial initialization. Next we will look into second category of runtime initialization, second category of initialization, that is runtime initialization. That is, during the execution of the program, if we are setting some values to arrays, then we call it as a runtime initialization. We have looked in one-dimensional array as well how we can set some values during the runtime. That is, we have made use of the for loop to read the values to these arrays one by one. If we look into this two-dimensional array, here major one aspect we should be very clear is it will contain the rows and the columns. So, in order to refer to this rows and column, we may require some variables. So, if we are using the variables, we can store some values of this number of rows and the number of columns in those variables. Here, I will use m for the number of rows and n for the number of columns. And here we need to run two different loops, two different for loops. One is mainly responsible for displaying the row content and one more for loop for displaying the column content. As we discussed in the pattern display, there also we were representing two for loops that to be in a nested format to represent the rows and columns. Same concept we are following here as well. So here the first for loop we started with the index value I equal to 0, and how long we should run this loop till we reach the m rows, that is I is less than m. Please note it is a less than m because this loop will be running till size minus 1 number of times, that is m. Suppose if it is 5, then this loop will be running till 4 times since the index value is beginning from 0 onwards, and we are incrementing this I each time. This is responsible for rows, and then we are using one more for loop for mentioning the column. Here we are using the index value variable as j, and here the column is there is, say for example, 5, then that is stored in the n variable. That's why we have mentioned j is less than n and j plus plus. And what is the major thing we have to write inside this for loop? That is, we want to read the elements into the matrix or to the array. Here, what is the array we are referring? That is A, and we are mentioning this I and j. What is this I and j refers to? That is the index values of this A. For the first time when this loop is executing, this I value will be 0 and j value will be 0. So in that particular location, that value whatever we are entering will be stored. Like that, we have to process entire two-dimensional array. That's why we are running over the loop here. And next we are closing this main loop. And this first for loop is responsible for rows display, and second for loop is responsible for column display. If we look into how we can read and display a matrix, or which is also called as a read and displaying the elements into two-dimensional array, we should begin with the first header file and with the main function. And here we are declared the array with the name A, and the size of the rows and column is mentioned as a 10, 10. It is mentioned the maximum values, and here we are using m and n to specify the number of rows and columns by the user. I and j are the variable used to run over the two loops. Here first we are taking the values of rows and columns from the user, and we are storing it in the variable m and n, and we are using the format specifier accordingly. Enter the elements of the matrix. We are reading the values of this array to the array. So first we will be beginning with the first for loop for reading the rows, and second for loop for reading the column values. And the major aspect what we are doing is, as we discussed previously, is we are reading the values from the user to the particular location of the array. This location is specified by mentioning the index values. And then if we refer in detail, what is this A of ij refers to? Initially this I loop will begin with the value 0. I will start with the value 0 here. That is, during that time j will be 0 with the 0 and 0 value. That is, A of 0 and 0, it is coming inside and it is taking the value, say for example 1, where this 1 will be stored. It will be referred as A, and I value is nothing but now here it is started with the 0 and this j value is also 0. That is, I and the j value will be A of 0 and j value is also now 0. So the location that we identified in the very beginning is A of 0, 0. So 1 will be stored in this particular location. Now next, which value is getting incremented? J value is getting incremented. J is now 1. whereas I will remain as it is. So here the next it will execute the scanf statement, that is, it is taking the next element from the user 2 and it will be stored in the location A of 0 and 1. Same way here the I loop will remain fixed, whereas j will be keep incrementing, that is, j is responsible for referring to the column. So it is successfully storing 1, 2, 3 with the I value 0 as a first iteration. Next, after this, the n value is set as how many number of columns here? That is 3. So it is going to check 3 is less than 2. N value is 4 is less than 2. 3. It is condition is false. So it will come out and I value will be getting incremented. So it is referring to the next row. And j initially it will be 0. So it is referring to A of 1, 0. This A is the array name. 1 is the index of the I and the j index is mentioned as 0. All the time, first it will be referring to the rows index and second is it is referring it as a column index. So 4, 5, 6 will be stored into the array. So this is how it will contain the elements at the end. I will begin from 0. J is also begins from 0 itself. And here, yes, we have successfully read the elements into the matrix or to the two-dimensional array. Next question is how we can bring the elements back onto the output screen. Same procedure we have to follow. That is, we have to use the first for loop for referring to the rows and the second for loop is for representing the columns. Now, please observe very carefully here. In the previous one, we were reading the elements from the user, whereas now the major task is to bring the elements back onto the output screen. That's why instead of scanf, here we are using the printf. Printf is responsible for printing the elements onto the screen. So now my work is to here to print the each element whichever we have read from the user. So it is going to print as 1, 2, 3, 4, 5, 6 as to the output screen. And here you might be getting one question. Why this /n is required? What is its necessity? That is, as we discussed previously, here after entering 3 different elements in a single row, we want to move our cursor or we want to move our control to the next line. After finishing the first with the value I equal to 0, we are supposed to perform this operation. That's why inside this for loop, we are mentioning a new line, that is /n forward / with n. That allows the control to move to the next line. And then after that, it is going to print the next set of elements. And while printing also, we could observe here /t. What does it mean? /t refers to we are printing with the spaces so that it looks like a matrix kind structure. So same way here with the same A of ij, we are referring with the each elements in this two-dimensional array. This is how the output will look like at the end. First, it is asking the number of rows and columns from the user, and here asking for the user to enter the elements of the matrix. So it is a 2 cross 3. So total 6 element is entered. So first 3 will be set to the rows, first row, and next set of 3 elements will be put to the next row. This is how it will be getting the output. If you look into the example program here, one simple program, it is asked write a program to find the sum of 2 matrices or 2D array. One major application of this two-dimensional array is performing the different operation in a matrices. Here, the major, if we refer to the two-dimensional array, here we are referring the major task is to find the sum of two different matrices. So it is clear that we should require two matrices. So here we are using two different two-dimensional arrays. One is A and one more B, and one more matrix we are using here to store the final resultant of addition of A and B matrices. And here we have mentioned 10, that is the maximum row and the maximum column size we could give is a 10. We could give any other values which is below 10. Now coming to the number of rows and columns, we are reading from the user, and we are asking for the user to enter the elements of the matrix A. Same logic we are using here as well to read the elements to the matrix. Here M and N is the rows and the columns of the matrix A, and here we are storing the elements to each of the location whatever the value is given by M and N. And then suppose if the user has entered 1, 1, 1, 1 as the matrix values, then in the A's matrix, in the position with the I value as 0 and 1, with the J value 0, 1, these elements are stored like this. Next step, here we want to take the elements of the matrix B as well. Here we need to read the two different matrices, and then we have to find the addition of these two matrices and store the resultant into one more matrix called C, and it is also a array. And then we need to display this C matrix back onto the output screen. These are the major tasks under this program. So here these contents are read in the same logic to the matrix B. Here one major change here is we are referring to the second matrix by the name B. That is, array that we are using is a B array. The name of the array is B. And 1, 1, 1, 1 is the content that we have stored. Now coming to the major logic that we have to perform. That is, we have to add this 1 with 1, and we have to store the result in this particular location in the matrix C. So how we can process? Here the rows and the columns of this matrix are fixed, which is as it is given by the user. So we have to run these two loops from M to N, and each index will begin from 0, I and J. And what is the major computation task? That is, in this A of ij, that is A of 0, 0 need to be added to B of 0, 0, and result need to be stored in C of 0, 0. This is how during the first iteration this major task will be going to execute. In the next iteration, this J value is getting incremented. That is A of 0, 1, that is nothing but 1, and B of 0, 1, that is nothing but 1. This and this element is going to be added, and the result will be stored in which location? C of 0 and 1. So this is how the addition of two matrices will be performed. As a major statement here, we are adding each elements of the matrix A with the elements of the matrix B and storing the result in the matrix by the name C in that particular location itself. This is how we could able to achieve this C of ij. This entire loop will be getting executed for I value 0 to 1 and j value from 0 to 1. And next task, yes, we have computed the result now. Matrix of addition of two different matrices. Now the next step is to display the matrix back onto the output screen. How we could do that? That is, sum of the two matrices, that is which is running from M to N, that is rows to the column and where the result is present, that is in the matrix by the name C of ij. So in the printf statement, we have to refer the final resultant matrix, and this is of a integer, so we are using the %d format specifier. Along with that, we are mentioning the /t, that is nothing but the space with it need to display the result. And here, what is this printf /n refers to? It is giving the new line after printing the first row. This is how the output will look like. Enter the element of, first it asks for the number of rows and columns. It is taken from the user, and it asks for the user to enter the element of matrix A and the B, and then it computes the sum, which is a resultant matrix, that is nothing but C of ij, that is nothing but C of 2 cross 2, and it will be printed as a output. This is how we can perform the addition of two matrices. Next program is to find the transpose of a matrix. What is meant by a transpose of a matrix? It is simple. The rows of the matrix, if we convert it into a column of a other matrix, then it will say that we have found the transpose of a given matrix. We are just converting the number of rows into a number of columns into in a resultant matrix. Here we are taking a matrix element. Here we want two matrices, that is A and B. This is the resultant matrix that we need to display, and I and J is to process. M and N refers to rows and the columns. These steps will hold good for almost all of the programs that we are working with the matrix. Here we are using the scanf statement to read the elements onto the matrix. That is, here we are representing to which array or the matrix we are reading the values. Next step, how we can find the transpose of a matrix. First step, we are following the same. And what is the condition that we have to perform? Here, what we are doing, this I refers to row and J refers to column. Here, B of ij refers to the resultant matrix. B of ij resultant matrix, how we need to store? That is, when we are storing the elements to the resultant matrix, we are changing this rows into a column and column to a rows. That is, we are storing first J, that is refers to the column, and then we are referring to the rows. How it looks like, that is A of Ji, that is first we are referring to the J, that is a column location, and then to the corresponding row. So in that particular element will be referred and it will be stored in the very first location of B of ij. If you refer to the example here, and finally the resultant is stored in B of ij matrix, and we are printing by using the corresponding printf statement. I'm not repeating this explanation of all these, which holds good for all the different kinds of the programs that we write across the two-dimensional array. So here we are printing the content of B of ij. If you look into the example here, I value with 0 and 1 and j value with 0 and 1. That is, the order of the matrix is 2 cross 2. That is 2 rows and the 2 columns. And the elements that I have stored is 1, 2, 4, 5 with the matrix A. What is this transport? Now, whatever we could see here as a 1, that is with the I value 0 and j value with 0, that need to be stored in the location j0 and I0. That is, now here it will be stored in this particular location. Whereas in the next, whatever we could see in this particular location, it need to be stored in this location. That we could achieve by mentioning A of ji, that is, whatever it is present in this j, that is 2 of I, that is nothing but in the second location, we are trying to print in this particular location. That is, we are just changing the rows into columns. and whatever present in this location we are trying to store in B of I and j. This need to be one value, 0 and 1. It will remain as it is. If you look into the example here, we are asking for the user to enter the column and the rows, and the user is entering the values, and we are finding the transpose of a matrix. That is 1 and 2 was present as a row, and in a transpose matrix it is converted into a column. Only major thing here we have to perform is we have to do one major statement, write one major statement inside the loop. That is, while copying, we have to refer to the column first and then to the row, and then we are printing. And one more program here to copy the element of one matrix to another matrix. Very simple code. All the other concept what we have discussed to read the elements of the matrix, all will holds good. I will not repeat the same. All reading two matrices A and B, and we are reading the M and N values. And here the major task here is we have to copy the elements of the matrix A of ij into B of ij as it is. We are not changing the rows and columns order. That's why we have given the major statement as the content of A of ij. Ij refers to for the first iteration, this will be A of 0, 0 will be copied into the location B of 0, 0. In the next iteration, it will be A of 0, 0 to the location B of 0, 1. A of 0, 1 to the location B of 0, 1. Like that, it will be keep processing. And finally, the final copied matrix is present in B of ij that we are going to print as a final resultant. And if you look into the example here, this is the one matrix and this is the one more matrix that we got it by copying these elements to the matrix B. Where is the final resultant matrix, copied matrix? It is present in B of ij. That's why when we are printing, we have to use in the printf statement B of ij. These matrix programs it will look complex when we look as a structure, but all the statements that we write here is all the same repeated kind of statement. We just need to check what kind of program we have to use, and accordingly we have to build the code. Here enter the rows and columns of the matrix A. Yes, we have entered, and elements we have taken, and just we are copying that element onto the matrix B of ij. That is B of 2 cross 2 in this example. And the elements of the matrix is present in this B of 2 cross 2 matrix that we are going to print element by element. We cannot write B of M and N because we are not entering only the rows number and column numbers. We have to process each element present in the array. That's why this is very important. Whenever we are representing the two-dimensional array, the major aspect is we have to mention two different sizes. That is, first size that we are mentioning within the square bracket is responsible for mentioning the rows, and second size which is responsible for column number. This is how we can work with the two-dimensional array. If it is something called as a multi-dimensional array, what it is? It is the number of rows and the columns will be more than 2 or more. In such case, when we call it as a multi-dimensional arrays. This 2D array, we can also call it as a multi-dimensional array. And if we look into the advantages and disadvantages of array, we have looked two-dimensional array as well as one-dimensional array. As a summary, if we now list out the advantages what we have observed with respect to array. Very first advantage here is, suppose why we went for using this array. Array is nothing but it is a collection of elements of same data types. Suppose now I want to store 100 students name. What I can do normally without using arrays, I need to take 100 different variables and I need to keep mentioning the student's name. Okay, that is some extent we can accept for 100 students. If it is 1000, is it feasible? No. We have to take 1000 different variables and then we have to store. It is not a good idea. As a solution to those kind of problems, we have come across the arrays. That is, it stores and retrieves the large amount of data without declaring many separate variables. Here we are referring with the one single array name, and we could mention, if suppose if I want to store 100 data, then I need to mention the size of the array as 100. And here the data type I can keep changing depending on the type of data that I am storing. That is the major advantage of this array. And while retrieving is also, it is very easy to retrieve by mentioning the particular block or the index where the array element which I want to access. That is also possible. And next, what are the limitations of this array? First one is, suppose if I have set the size of the array as 5. During the execution time, I found that I want more elements to be stored. Then it is not able to change the size of the array. That is, it is fixed as it is declared in the very beginning. That is a one major disadvantage. And here, suppose if we want to insert any element between the two elements, suppose if there is three different elements as 10, 20 and 30. Between 20 and 30, if I want to insert as a 25, then it is a very difficult, because I have to keep moving this, shifting this 25 to the next location, and then I have to keep adding the element. That shifting operation need to be performed from first location to the last location, and then I need to make the space for adding the new array element, and then only I can keep adding the new element. That is the one more disadvantage. And here one more, if suppose if I have set the size as 100 in the very beginning, that is 100 memory location is allocated for that particular array. But during the usage of that array, I might have hardly allocated 2 to 3 elements to that. The entire, all the remaining 97 content is become waste. That is, all those elements will be set with some garbage values and it is not in a used condition. That is, memory space will be wasted much with respect to the arrays. These are all the some of the disadvantage with respect to array. These disadvantage can be overcome by using one more kind of data types that we call it as a list, or we call it as a linked list. This is all for this particular session. We majorly looked into three different aspects. One is how we can declare the two-dimensional array, how we can initialize the two-dimensional array, and we understood this two-dimensional array, or which is more famously called as a matrix, with different example programs. Thank you for listening.